differentiation is related to frequency response, where you need to design your Nyquist diagram. Yeah, we call Nyquist diagram. Okay, so basically this is the frequency. Okay, this chapter is try to focus on the frequency response. Okay, data. Okay, what this frequency response data I will explain after this. So what we will do now is we just concentrate on the frequency response, where before this we just concentrate on S, right? S continuous, but now we need to change to j omega. So all the S character we need to substitute to j omega to become frequency. Okay, so what happen now ni, apa yang akan terjadi if we have something like this, sorry, here. So based on the frequency response, we need to change the okay, we need to change the S to become j omega. And then same, K is constant, same, and T is time constant. S is we need to change to j omega. Nah, so this is the procedure how to we focus on the frequency response. Okay, before we go through the drawing or sketching Nyquist, so they have some several important what we try to look at on the system itself. For example, now, okay, even we have K as the system, we have G as a system, and we have H as the subsystem. Okay, for the all overall system, what we have here, so we have U and Y. Okay, okay. Now our transfer function in Nyquist as well, we just concentrate on the open loop. So we have K, G, H. Open loop, not to come up with the manipulation become closed loop. We just focus on the open loop as well, like what we did in root locus. Okay, so basically K, G, H is also have the own they have their own formula, or they have their own the mathematic model. So for example, maybe K is equal to S. Maybe G, what we have done, we have K, we have value K, okay, maybe we have 1, S plus 1, maybe H, maybe we have 1 over S. So every model, they have their own principle, or they have their own characteristic. So before we go through the Nyquist procedure, we need to know the each element characteristic. Okay, ada lagi nak datang, ada lagi. Alright, kita tengok. Abdul Rahman ada sini. Abdul Rahman.
Yes.
Okay, how are you?
Alhamdulillah.
Alhamdulillah, good. Okay. Wait. Alright. So now, okay, before we go through the Nyquist plot diagram, we need to consider several concepts. So one concept we call differentiation. Differentiator. Okay, and we have also integrator. We have integrator and also another one. Okay, tak apa. So now we need to consider all this. Please be careful. Okay, on this frequency domain, they have their own concept. If we have differential this differential concept, where we have G S equal to 1 over S, differentiation is the S, okay, S. So now convert to the frequency response, we need to substitute S become to J omega, and also we have S equal to J omega. So from this, okay, what the important things we need to, okay, once you want to design the Nyquist diagram, you need to know they have two point where we need to identify the gain and we need to identify the phase. Okay, in this here in this case, S equal to J omega, GS equal to S, our differentiation ni, we have our own gain where our own gain is omega J omega modulus is equal to, we have omega, and our phase, this is we call gain. Gain. This is formula for gain. This is the concept of gain for differentiation. And for the phase G J omega, okay, we have negative 90 degree. Okay. Opposite to the differentiation, we have integrator where we have GS equal to 1 over S. So where we need to substitute to J omega because we refer to the frequency response. So we have 1 over J omega. Then for the gain, of the integrator, we have G gain and we have 1 over omega. And we have phase. For this type of integrator, we have J omega equal to positive 90. 80 degree. Okay, biar dulu. And we have another concept where we call okay, first order lag. Lag. Okay, our standard standard equation or standard transfer function first order lag is where we have GS equal to K 1 plus TS. Yes, normally in this chapter, Nyquist, we focus on the first order. Second order later. Okay, it's first order. And also you need to fulfill the test 2 in first order as well. Okay, so now from this, okay, we have convert to the frequency response. We substitute S equal to J omega. Then we have K plus T omega, Tj omega. Then for this, okay, for this gain, we have J omega, and we have K gain and 1 plus T omega square root. Then for phase, we have G omega equal to negative inverse T omega. Okay, so because of what? Because of in our system, it come from our sub system. So if you can see ataupun if you can look, refer to the previous chapter, once you design the model, and then all the model, if we have, for example, if our model have 3 elements, spring, damper and mass, so it should have 3 block, right? Block is represent as the stiffness of spring, mass of this block diagram, and also C. So means that every block, it will have their own they have their own mathematic equation. So some mathematic equation, okay, but most of these mathematic equation, they have their own concept, which is maybe they have come from the integrator, maybe they have come from this differentiation, maybe they have the first order lag. So maksudnya benda ni kita kena faham lah dia tu berada di mana, maksudnya dalam group konsep apa. So if they have include in differentiator ni, okay, they have gain. This is the formula of their own gain. This is their for the angle of this own phase. This is the integrator. This is the formula of 1 over omega, and also this is the phase, and so on. Maksudnya sama juga, it same with this first order. This is the gain, and this is the phase. Sebab apa? Because we need to combine all the block diagram. It become into one block diagram to complete as a one whole system. Okay, so this is the concept of we try to understand every concept what we have here. Okay, now we try to come up with this example. Kita tengok the example I will show here is to how you relate ataupun we need to relate all the equation are related into our polar graph. Okay, we want to come up with Nyquist diagram. Okay, the first question, before I explain the example, let me I try to explain a little bit on the concept on behind this Nyquist. So for example, now we have several G. Okay, so we have a lot of, maybe we have 2 or 3 G in one whole system. Okay, so we have U and Y. So in each G is representing their own concept, maybe integrator, maybe first order lag, and so on. Okay, tak ada masalah, it doesn't matter about that. But okay, how we define the gain and phase? Okay, for example, now they have their own G, they have their own G2, they have their own G3. For example, we have their own gain, we have their own phase, and we have their own G2 phase. Okay, and also we have their own G1 phase. So from this, okay, we need to total all these G for the gain, and also we need to do summation of this gain as well. So for example, let's say okay, now for example, our G now we have S, our G2 is 1 over S, but in our case of G3 is 1 S plus 1, S plus 1. Okay, so we have three different concept on each block diagram. So what we can do now, for example, we have G1, we know that is equal to 1, and then we need to change to the frequency response. We have J omega, and then we need to define the gain, find the gain J omega. So we know that our gain is omega, and then our phase of this gain is positive 90. Okay, positive 90, right? Okay, so we have another one. We have G2. We know that, okay, our system is 1 over S, so we should change to the frequency domain 1 over J omega, and we have G2 J omega, and we have 1 over omega, and our phase for G2, what we learned just now, we have negative 90 degree. Then we have G3, we have S 1 S plus 1, so we have G3 WD sama dengan we have 1, 1 plus j okay, j omega, and for the gain of G3 we have 1 root of 1 plus omega square, square, and for the phase of G3 j omega, so we have negative inverse tangent omega, okay, omega. So this kind of what we need to show, okay, show in the analysis on in the system. So okay, we have three system, then we need to show every system based on their own gain and their own phase. Okay, so from here what you need to do is you need to come up with the table where you need to define ataupun come up with the value of omega, okay, and then you need to come up with the gain of G1, you need to come up with the phase G1, you need to come up with gain G2 and also phase G2. Same what we need to do G3 for gain, and then phase for G3 for gain. Okay, so the value of omega you need to try and error. Normally we start at 0 until you can any value you like. So maybe 0.5, maybe you can put 1.5, 2, 3, 5 and so on. It depends. Don't put too many value in omega because it will take time lah to come up with this diagram. So maybe 6 to 7 value is enough. At least you can come up with a line shape of this particular system. So normally in test 2 they will give you the value of omega, so don't worry about that. You only calculate all the value this, okay, to get the value of gain and phase. So from here, okay, what I want to explain now about this, not to calculate on everything here because we have the own example after this. Okay, if you are looking for this, okay, table, you have your own gain G1, G2, G3. So you need have the value of this G1, G2, G3, and then you should put the total of our G. So mean the gain total means we have G1 multiplied by G2 multiplied by G3. So they are should be multiplied. Then you will get the answer of the total of the system. And for the another one for the phase, so we have phase G1, we have phase G2, we have phase G3. We are not multiplying, we are summation, we are tambah aja, we are sums all the related to the angle into the single phase. Okay, for example, now maybe we have 10, 5, 2 means that you need to add, then we will get 70 degree. Okay, so depend on that. So now, okay, refer to our polar graph. Okay, refer to our polar graph. We only need these 2 points. Okay, even we have 3 subsystems, but we already combine become one system, then what we need only 2 points where we only need gain value of total gain and value of total phase. Phase. Okay, now here this is very important. Okay, let's we do simple example first. Okay, the simple example first. Okay, if we can see ataupun if we can look into the okay, alright. So we have simple example where we have 4, we have S plus 2. This is one system. Subsystem we have 2, 4. We have 2 and we have 4. This is also system. Okay, and we have U as the input, Y as a output. So from here we have definitely we have two subsystem where we can namely SG1, we can namely SG2, G2 betul. So jadi sekarang ni apa kita nak buat adalah what we can do now, we need to try to detail out of the G1 and G2 to find the gain and the phase. Okay, now we try to concentrate on G1 first. G1, so now our G1 S equal to, we know that S plus 2. Okay, basically we need to consider as the first order system. Our concept of first order system is K1 plus TS. So now from here we need to come up with the standard form for the first order. So now if we try to follow the first order, we need to try to get this 1 plus something S. So from here to get 1 here you need to over 2, so means all over 2. So we have 4 over 2, 2 over 2 plus 1 over 2s. So from here we have 2, 1 plus 0.5s. Okay, so from here we need to change to the time domain to frequency response. Is we have j omega equal to, we have 2, 1 plus 0.5 j omega. Okay, so once we have this standard form for transfer function for G1, so we need to declare G1 the gain of that system. So our gain is 2 root of 1 plus 0.5 omega square. Okay, jadi we have phase of G1 is negative because it's the first order lag. So we have 0.5 omega. Okay, so finish for G1. For G2, okay, ada apa-apa soalan tak sebelum ni? Ada apa-apa soalan? You have any question related to this example? Class?
Doctor.
Yeah.
Why did you turn the 4 over s plus 2 into a 2 over 1 plus 0.5s?
Okay, too easy to get this ni. Sebabnya, okay, because of I try to train this concept because after this you need to design the one graph. Okay, one graph we call Bode diagram. Their concept is to still same with what we did in Nyquist, but they always follow the first order system. So you also can use directly, okay, use the gain of this one. For example, now if you don't want to change this, it doesn't matter. It will give you like it will give you the gain of G1. Okay, for example, now if you don't want to refer to the first order, you will get this 4. Okay, we have j omega, so omega square plus 2 square root pun boleh, tak ada masalah. Tapi nanti in term of finding phase, the formula of the finding phase, we have negative tangent inverse T omega. So this T is related to here, apa nama dah? Here. Jadi nak tak nak kena ni jugalah. Boleh, tak ada masalah. So you can also, if you don't want, Ataupun buat siap-siap pun boleh, or you can use ataupun bahagilah kat sini 1/2 sebab you nak T, the value of T ni sebenarnya. Siapa tanya tadi?
Saya Dr.
Siapa?
Darren.
Darren, boleh. Boleh betul. Boleh Darren. Boleh dapat tak?
Boleh.
Boleh, terima kasih. Ada lagi tak? You have any question? Ya.
Sir?
Ya.
Kan ada S apa dengan 1/S, 1/S plus 1 kan. Boleh tak? Boleh jadi ke yang dia punya bawah tu quadratic S square ke apa?
Oh, dia macam ni. Okay, 1/S tu dia maksudnya macam ni. Okay, saya skip sebenarnya. Okay, dia macam ni. If we have, let's say 1/S nah. Okay, 1/S ni, if we try to convert to the frequency to respond, we have 1/j omega. So if we are try to looking for the gain, okay, it will go to 1. Actually they will go j omega ni, disebabkan j power of 2 ni dia boleh cancel out, it become 1. J power of 2 is 1. So omega and omega, that's why we can get 1/omega. Boleh tak? Tu sebab tu saya terus je, I straightforward get this, because I believe you learn this when you are in electronic subject. Ingat I kerja tak ingat tapi you learn this, kita pernah belajar dalam elektronik. Siapa tanya tadi? Siapa? Firdaus Siapa?
Hazim.
Alip. Boleh Alip? Betul tak apa yang awak tanya ni?
Ya.
Betul okey, baik. Okey, tak apa, biar dulu. Okay, so now we have G1. Okay, we have, we need to identify the gain of G1, phase of G1. Okay, so we continue for G2. For G2 now, okay, G2, G2 nak color apa? Color katalah biru. Okay, so G2 apa tadi tu? 2, 4. Okay, same. Kalau 2, 4 bermaksud kat sini G2 S equal to 2 S plus 4. So okay, so we have G2 J omega, we have 2 J omega plus 4. Okay, so if you don't want to make follow the standard of first order system, so you have straightforward lah. Okay, sini tak ada masalah, you just straightforward. We have omega square, 4 omega square root. Okay, atau kalau nak, if you want to follow, it will get like this. Kalau nak, you will get j omega, it will go to, saya padam ni. Kalau nak, you will get this time 4 and time 4 tu. So jadi ni 4 jadi 0.5 1 plus 0.25 S pula omega square. Boleh dah. Okay, omega square kuasa 2 time here. And we have phase for G2 is negative, same negative. So we have 0.25 omega. 25 omega. Okay nah? So we have two system, 2 gain and 2 phase. So now we need to combine. Jadi kita nak kena combine ni. So jadi kita nak combine. So bila kita nak combine, okay, my advice is you need to come up with table to get proper. So at least your mark less loose lah, maksudnya kurang hilang lah. Kadang-kadang dia nak come out kan, kadang kita big mistake, nak running of time, kita akan ada careless lah. So jadi kita nak kurangkan careless tu, we need to, okay, semua tu kita nak kena consider lah, sebab time is very constrained. Jadi while we have omega, we have G1 for gain, we have phase for G1, we have gain for G2, and we have phase for G2, and we have total gain G1 multiplied by G2, and we have summation of G1, summation of G2. Ni campur, you need to put plus. Okay, so plus, so G2. Okay, because of only we have G2. So for the omega, don't worry, in test 2 they will give to us the value they will provide. So for now, example, we try 0. Okay, based on the example we have in textbook, we have 0, 0.5, 2, 3, 4 and 10. Okay, so from here, this value you need to substitute to the formula, formula gain G1, G2 and also phase G1, G2. At last you will get, macam mana nak buat? You will get, mana lagi tadi ada? Sini. Okay, you will get macam ni. Okay, dia dapat ni. Tadi sebab ada kelas tadi, jadi saya malah nak pecah padam, so I will share with you yang ni lah. So now, okay, based on the calculation, you will get every G1 based on the every value what we have suggest. Jadi kita dah dapat. So the total, what we need now is the total of the gain G1, G2 and the summation of G1 and G2. So now we are try to refer these two to come up with our Nyquist block diagram. Okay, selesai So yang ni ada apa-apa soalan tak in term of we come out all the equation to produce the gain and phase, and we try to come up with the table to show the every single value, single value based on the gain and based on the phase. Ada tak soalan? You have any question related to this discussion? Ada tak? Okay. So kalau tak ada, please don't skip. Maksudnya every you do this work, analysis, so they have their own mark. So for example, if you try to come up with this, G1, so you show the gain half mark, you show the phase half mark, so mean every system get 1 mark. So now we have here 2 mark. 2 mark for the to show, just show the concept of gain and phase, and then another mark is the value, to get the value of every single omega what they suggest, what they provide to us. So jadi setiap ni ada. So maybe around here if we can get maybe for example 1, 2, 3, 4, 5, 6. So maybe we only get 3 mark for 3 mark for schedule, 2 mark for the showing the formula gain and phase. Okay, so the rest is to the rest mark is come out with the diagram to refer to diagram. So for example, now we have this. Okay, the important thing in this apa dia panggil Nyquist diagram, you need to see the range of gain. Okay, now what happened in this example, we only have the maximum value is 1 and also minimum is 0.07. Okay, for the phase it doesn't matter because of we in our graph paper we have 360 degree. It doesn't matter. It's not quite stress. Jadi yang stress adalah yang kat sini. It's very apa dia panggil challenging is this. How you decide the range ataupun how you decide the scale. Okay, scale tu, skala dia tu. Okay, we move to another. Okay, sekejap. Mana saya punya tu tau. Sekejap. Ni okay ni. Okay, this. Okay, this is your polar graph. Okay, ni nama kertas paper ni nama dia polar graph. Okay. Okay, what we have now, we have the circle, and we have the straight line. Straight line. Okay, we have, if you can see here, we have 0, and then every angle is represent as the 10 degree. So 10, 20, blah 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 until 360 if we have positive angle. If we have negative angle, it will go to ni lah, opposite direction. Tak ada masalah. Okay, now if you can see just now, if we can see our range of gain is 0.07 to 1 to 1. So we start at here. Start here is as a 0. Okay, so now until here. Okay, now you need to balance, to give some balance scale. So if you can see here, we have how many cycle, berapa bulatan? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, mostly 10, maybe 10. So means that maybe we can assume ataupun suggest one cycle is around 0.1. Okay, mungkin 0.1, 2, 3, 4, 5, 6, 7, 8, 9, mostly 10. Okay, tak apa. Katalah one cycle, 0.1 cycle is represent is 0.1 scale. Okay, now we need to draw. Okay, sekarang nak kena draw ni. Jadi draw, I try to zoom in. Jom, saya try zoom boleh nampak ni Okay. So now 1 So here I can put 0.2, here 0.4, here 0.6, here 0.8, and also somewhere here 1.0. Okay, so refer to our table. So 1, our 1 now, our 1 sini okay, our 1, our angle is 0. So 0 means we have 1, 0. So tak ada apa-apa lah, we just here 0. Okay, next. So we have 0.97 is our angle is negative 21.1. 97. So here 97. So we have 97 is somewhere here, but the angle is negative 21.1. 21.1 is somewhere ni. Kata is here. Katalah sini here. Okay. Katalah. Alright. Okay kena hati-hati kat sini. Be careful when you mark. Okay. Jadi next is 6371. Yes. So 63, 71. So 63 here, somewhere here. Kalau if you focus on this, kalau ni focus zoom, ni zoom out ni, zoom in ni. Ni saya zoom dulu. Okay. Dekat sini dia, every cycle ni they have 10 line. 10 line. So means that every point at one line it representing as 0.01 lah. Okay, benda tu lah, tak ada masalah lah. Okay, so biar dulu. Okay, now 63, 71. 63, so 13 here. 71 is 50, 60, 70. 70 is around here. Ni lebih kurang So here. Okay. So next is 44, 93, 44, 93, 44. Okay, 44, 93. So 93 is 90 here, somewhere here. Kira elok-elok. You need to come up with good point mark. Okay, jadi kita ada lagi 31, 108. 31, 108, 31, 30, 0.31, 108, 100, 110, somewhere here. 31 should be here lah. Okay. Okay, last, okay. Last 0.07, 146, 146, okay, 001, somewhere 007 is close to 00 ni lah. So 14, 146, 14, 15, sini lebih kurang. Okay, now we have 5, 1, 2, 3, 4, 5, 6 not. So you need to sambung continuous ataupun do the some sketching based on your skill, your hand free skill lah. Cari elok, this is not good skill, lebih kurang lah sini. Okay, lebih kurang. So okay, selesai. So this is one of the simple example we call Nyquist diagram. So this is what you need to answer in test 2, but not finished yet. Not finished yet because you need to do analysis on this graph. Okay, before we do some exercise, before we try do more exercise, I want to explain to you. Saya nak cerita dulu. Okay, so this is your polar graph. Okay, some cases, okay, for example, okay, we have, okay, in the scale of polar graph, we have number of scale 0.1. Okay, this is 0.1. So if you can see 0, this is 0.1 is just a circle as well. Sama je macam bulatan tadi. Okay. Lukisan. If we have, for example, we have case. Okay, first case is go to like this. Okay, it go to like this. Okay, this one maybe they go to 0.6. Okay, tak apa dia. Then another case, it will go to this. The touch 1.0. This is 1.0. Another case, they not touch, they still touching but over 1.0. 1.0, 1.0. Okay, so we have three different response. Okay, three different response where, okay, for the stability criteria, okay, this procedure frequency response, they mention us if we are to identify our system is stable, we need to consider the intersections in the gain line ni must be less than 1. Means that if you can see, if we have this brown color, they are below than 1, and okay, this is stable system. But if we have this system is go to the cross exact point 1.0, mean our system is critical stable. Okay, uncritical mean the critical condition. So if we have the intersection or crossing the axis of gain above 1.0, means that this system in unstable. So kita boleh tahulah mana tahu if they have the question to you need to explain the stability on the concept of Nyquist, then you can show this result ataupun this figure. So sebab apa kita nak cari? Why? Because we need to find something in here. If we have this circle like this, means that we need to redesign model. But if we are in around ataupun in in the boundary of 1.0, means our system still stable. What we can say just now, our system macam ni tadi, for example, so means we are unstable as well. Sama lah macam tadi sebab they are not beyond to 1.0. Okay, this is the theoretical for the stability. Okay, fine Okay, we try to look to the sekejap saya tengok ada tak. Sekejap. Mana contoh tau. Sekejap. 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 Saya tengok mana pula terpadam ni. Okey. Ni. 40. Kejap. 40. Okay, alright. Okay. Selesai. Okay. Sekejap. Okay. Sekejap. Apa nak buat? Share. Sekejap, saya ambil masa sikit mungkin satu suku ke habis minta maaf tau. Okay, sekejap. Mana tadi? Okay. So this is the example. Okay, this is the example question for test 2. Test 2 semua dapat nampak ni. Test 2. Okay. So test 2. Okay. So they give us this block diagram. Normally 3. Jangan risau. Selalu 3 lah. One is K, one is G, one is H. This is the standard for engineering problems. Okay. So now from here, if the A, plot the Nyquist diagram for the system above. Use omega 0, 1, 3, 5, 8 and 10. So you need to consider on this. Okay, to find the gain and phase. Okay, so now this. We have our system open loop. We have 2S multiplied by S plus 1 and also S plus 5 multiplied by 5. So means our open loop system is 10. We have S plus 1 and also S plus 5. So in this case, okay, how many subsystem we can divide? We can divide 3. Betul? 3. One is G1, we can represent as equal to 1. Maybe G2 is we can represent as S plus 1. Maybe G3 we can represent as 10 over S plus 5. Fine, okay, 5. Alright, so selesai. So finish on this. Alright, so jadi ada soalan? Okay, any question you want to ask before we do further calculation? Kelas ada tak?
Doktor, boleh jadi ke dia kuadratik?
Kuadratik ada tapi jarang tanya lah. Susah sikit nak tanya, susah sikit nak buat. Is possible tapi tak boleh lah. Tu dera maksudnya. Boleh. You can get the quadratic tapi normally in test tu they will give the simple example because the evaluation is to come up with the understanding how you design the Nyquist diagram. Fikir yang positif, fikir yang dia can tapi tak boleh tanya agak ni lah. You don't have time lah. Basically you need to consider on the time duration because every question you need to answer less than 30 minutes something, maybe 30 or 40 minutes something. If you give you the complex of the equation, it will difficult lah, it will take time lah, susah sikit lah. Okay, masih jarang tanya. Untuk Nyquist is very difficult, but locus yes you can use, okay, because we are related to stages. Tapi kalau Nyquist is very difficult because you need to consider everything. Okay, tak apa, biar dulu So nanti kita akan tengok lah. I will give 2 or 3 example test 2. At least you come up with the own answer and then we can discuss. Okay, now we have 3 system. So we have G1. So G1 is represent as 1 over S. So we need to change to the frequency response. So we have 1 over J and then direct okay, you will get ataupun you will find the gain of this system, so 1 omega. So the concept of G1, because of this is the integrator, right? So we have negative 90, and
Doctor,
yeah.
Previously you said that integrator is positive 90 degree. So which one is it?
Integrator, differentiation.
When you
Saya cakap salah Sekejap.
the one between
Okay,
differentiator and
ni
integrator.
Integrator is 1 over, Allah, salah. Zarambi, salah. 1 over S is negative sorry. S is positive. Aduh, minta maaf sorry. Siapa tadi? Darren siapa tadi? Okay, sorry Darren. Betul. Kalau now S is positive, kalau 1 over S is negative. Terima kasih banyak-banyak. Selamatkan awak kawan-kawan. Okay, so ni 1 over S is negative. Okay, kalau S is positive. Sorry, thank you very much. Okay, alright. So kita continue Okay, so now is integrator 1 over omega. So kita ada negative we have negative 90. So from G2 S equal to 1 S plus 1. Saya rasa ni we don't have any problem because straightforward. So we have 1 plus J omega, and then we have G2 J omega. We have 1 root of 1 point J omega. Okay, so from here we have phase on G2 is negative negative inverse of omega. Okay, omega. So now we have G3. Okay, G3. We have G3 for S is we have 10. You can also use direct if you want. So we have G3. If you don't want to make is first order, you can straight away can get 1 pi campur dengan J omega. So we have gain of G3. Boleh, tak ada masalah. You will get 10 root of phi square omega square pun boleh. And if we consider the phase of G3 should be negative tangent inverse. So here T omega, our T is 0.2 omega 2 omega. Kalau kita buat ni 2 omega lah. Kita phi multiply by over 5 this 1 over 5 is 0.2. This is 0.2 is T. Okay, so we have this all the related on the system. Then you should make the schedule omega. So G1 phase G1, G2 phase G2, G3 phase G3, and lastly total of G1, G2, G3, and you will get summation of G1 plus summation of G2, summation of G3. Okay, so omega 5, 8, 10, 5, 8, 0, 1, 3, 5, 8, 10. So 8, 10. So from here you need to substitute all the value, and then I give the answer. Give the answer, you will get this copy. Mana pula ni? Okay, so here. So ni adalah, this is the total. Okay, total of the gain, and this is summation of the phase. Nanti saya akan share. I will share this value in our group. Sama. Sekarang ni kita nak buat apa? I will show you the sketching of the root local Nyquist. So from here, okay, now from here we need to draw to our holograph. Jadi kita nak tengok holograph ni, so kita kena buatlah holograph mana tadi. Okay, saya buang dulu. Sekejap. Awak ada kelas kedua kejap Okay. So based on our our system ni ataupun our analysis, our maximum gain is 1.3, is equally approximate 1.4 lah, 1.4 and then 0 should be okay. So 1.4, okay. Refer to our mana ni? Okay, here. Okay, 1.4. So means berapa? 1.4. Our scale, reasonable case scale, so is equal to maybe is around 0.2, 0.4, 6, 8. Boleh So in cycle we can consider as 0.2 lah 0.2. So we can consider as 0.2 every cycle. So here 0.4, 0.8, 1.2 and 1.6. So every here 2 2. Okay. So from here, refer to our table. Infinity negative 90, so no need to tick lah sebab kita pun tak tahu where they come from. Infinity somewhere else, tak apa, biar, leave it. So we have 1.4 equal to 146. So 13 something, 13 here, kita kecilkan. Okay. So jadi 1.3 here somewhere. So 146 negative 146. 146 is 90, 100, 110, 240, 50 ni. 146 is 13 here 13 kan. Sini here. Okay, here. Lebih kurang. Okay, finish. Then apa lagi? Kita tengok lagi 0.2. Okay, 0.2, 192, 192, 1. Okay, 0.181, 0.8181 ni 0.2. Kira lah somewhere here close to 0.2. 192 is 180, 192, somewhere sini lebih kurang. Okay, so apa lagi? We have 0.0, 0.06, 214 kecil lah. Okay, 0.05 lebih kurang sini lah. 214. Nah, 214 here 200 sini. Lebih kurang 0.0 sini lah. Sini lebih kurang sini lah. Lepas nanti awak akan dapat lagi kecil sini, lagi kecil sini. We have to very small. Tak apa, biar je. So here okay, tak jauh beza lah. So jadi kita ada dah. So what we can do next? So we need to sambungkan. So you need to draw the line. Okay, carilah line, carilah yang sesuai. Maksudnya nak guna pembaris, janganlah pembaris is very straightforward. So jadi kita akan gunalah tangan ke macam mana ke yang cantik-cantik sikit macam tu. Lebih kurang lah dia akan jadi macam ni. Dia tak kena ni, tak lawan. Okay, macam ni. Okay. Alright. So this is number 1.0. Ingat 1.0 dia stable. Still stable because closing in the region 1.0. This is 1.0. Okay, dia stable. Okay, ada soalan tak until here? Class?
Doktor,
Ya.
Saya nak tanya, macam mana kita nak tahu yang graf ni stable atau tidak?
Graf stable yang tadi saya cakap, kalau dia bersilang, okay, bersilang pada paksi yang ni, 0 ni, okay, dalam boundary 1.0, bermaksud dia stable. Kalau tiba-tiba in case we have another point here. Betul? Okay, so jadi here. So jadi here. So jadi kita akan kena ikut lah. Nak tak nak kena ikut lah. We just follow the point what we have. Ini lah contoh. So now the intersection of 0 ni, line ni. Okay, kat sini ni, kita punya 1 is here. But our system cross to more than 1.0. Means our system not stable. Sekarang ni, now, our line crossing be in between, maksudnya in between 1.0, maksudnya within a range 1.0. Nampak tak? Ni dalam bulatan ni dia duduk kat sini, tak kisahlah dia nak ke sini ke sini ke sini ke, stay stable. Jangan luar daripada 1.0. Anything 1.0. Boleh tak? Kelas?
Boleh tak?
Okay, baik. Alright. Okay, nah.
Betul tu saya tanya satu soalan terakhir yang
boleh.
Dia yang tadi yang doktor buat soalan test tu macam mana G1, G2, G3, sebab saya tengok macam saya agak pening kat tu.
Pening? Okay, sekejap.
Dia G1, G2,
tak apa, relax. Okay, so jadi macam ni. Sekarang ni kalau kita lihat kat sini, okay, so you need to multiply all the block diagram. So this block diagram represent SK, this represent SG, this is represent SH, betul? So jadi sekarang ni you need to multiply, then multiply lah semuanya. Ini multiply by ni, multiply by ni, then you will get this transfer function open loop. Okay, this is our system, open loop system. So from here you can come out lah by your own strategy. So means kalau contoh kat sini you can get, okay, is equal, kalau kita lihat kat sini, if you can see here, okay, 10 over S plus 1, S plus 5. So basically it come from 4 actually. For concept lah, for principle. 1 is gain, 1 is 1 over S multiplied by 1 over S plus 1 and 1 over S plus 5. Betul? Setuju?
Setuju, doktor.
Okay, so jadi 10 ni you can put anywhere you want. You can also put here, also you can put here, ataupun yang nak you put here. So as long they are in 3 system, 3G. Boleh?
Okey doktor, boleh.
Okay nah, clear. Terbaik. Alright. So jadi kita nak buat ni satu lagi. One solution. Okay. The question, okay, satu lagi. The question ask us B, normally just 2 mark, never mind. Okay, at least you have 8 mark in your hand. 2 lagi markah adalah 2 more mark is find the system gain margin and phase margin. Phase margin and gain margin from the diagram. So from the diagram, okay, now you will get this. Okay, apa dia? So I zoom sikit. Zoom. Okay, apa dia ni? Okay, kalau kita tengok kat sini, apa yang kita dapat kat sini, contoh lah. Contoh. Okay, sekarang ni kita dah dapat. Okay. We need to find the range of intersection, this intersection. Kita buat lah, depend on kita punya free hand lah. So katakan duduk sini ke sini tak ada masalah, dia plus minus yang risau lah. So now from here, start from here to here, exactly we can get the range of these 2 points. So maybe this is 0.2, 2, 4, 8. Macam salah je. 2, 4, 6. Betul. So 4. Okay. So it's around 2 here. This is 4. Must hopefully kalau kita kira nanti you will count. This is we call range of X. Range of X is approximately atau estimate 0.3. Okay. Our gain margin, the formula is GM, gain margin, and we call GM equal to 1 over X. Where is X? X is the range. This range, this panjang ni, apa dia panggil ni? Jarak ni, distance, the distance, intersection distance to 0. So jadi sekarang ni we have gain margin is 1 over 0.3. So you will get berapa? 3.333 so far lah. Okay. So this is gain margin. Okay. But for the phase margin, okay. So dipanggil simbol ni. Simbol ni apa sigma, bukan sigma, gamma. Okay. So this symbol, okay, it represent as phase margin. So how we calculate phase margin? So we refer to 1.0. Okay, saya kecilkan sikit. 1.0. Here 1.0. You drag to the closing of the line what we done. Dan ni closing dekat sini. Okay, ni closing dia ni. Ambil ruler, use your ruler, and then marking as the straight line, refer to 0. So your gamma, it will show in between our line to the 0 ni. So kat sini. So you can straight dapat lah. Normally you will get berapa ni? 10, 20, 30, 30 what? 30 something, maybe 31 something lah. And then this is your gain, phase margin. So buat dalam ni juga, you just include your value of phase margin and gain margin inside ataupun in the graph. So jadi 31 degree. Dah selesai, finish 2 mark. 1 mark for G margin, gain margin, 1 mark for the phase margin. Ada soalan tak? This is the test 2 cover. Kita cover test 2 until this.
Doktor, phase margin macam nak buat?
Phase margin ni maksudnya macam ni. Phase margin, kita dapat intersection 1.0 ni. Betul? Line ni, apa-apa kita keluar line ni, yang bersentuh je, bersilang je dengan the intersection go to 1.0. Okay, ambil ni as a reference. Lepas tu gariskan guna dash line ni kepada kosong ni. Lepas tu nanti kita ambil angle ni. Angle ni start from 0 ni. 0 to kita punya line ni. So kat sini lah dia punya nilai dia. Faham tak?
Faham betul, faham.
Contoh kan, contoh lagi satu. Okay, contoh. Bagi clear ni. Nanti, okay, katalah contoh. Okay. So this is number 1. 1.0. Okay, you buat macam ni. Dapat ni. Okay, katalah daripada somewhere else lah. Okay, jadi sekarang ni 1.0. Tak kena ni. Okay, here. Ni tak kena ni tak bagus ni. Okay. So for example here, this is the closing intersection in between our line and 1.0. Sini.
Oh, ya?
Ni. So then you mark, kita buat dalam benda ni. Here.
Kosong.
So, kosong. Jadi dapatlah ni. Alpha dia ni. Okay. Boleh tak? Ni sekarang ni. Ambil line ni as a reference. Lepas tu kita ambil kat sini. Daripada sini. Ni lah angle gamma ni. Gamma ni is the phase margin. So nanti kan kita akan nampak. We will see how many angle. Tak payah guna jangka lukis projector. You will get the exact value. Each angle is 10. Represent as 10. So 10, 20, 30, 40. So for example now maybe 50. Macam tu lah. Terus dia dapat. Dapat tak gambaran?
Faham doktor. Terima kasih doktor.
Okey, baik.
Doktor,
Ya.
untuk value dalam table tu, setiap value tu kena tunjuk jalan kerja ke?
Kena. Markah. So jangan skip. Nanti kalau skip, katalah awak ada mistake kat mana-mana, nanti tak ada, dia tak boleh nak menolong lah. Kan, nanti tak boleh, awak kena kira. Every ni ada, kena buat. Sebab ada markah dia. Ada markah. Cuma yang ni je masalah dia. The problem is this. Ni line ni. Ni line ni depend pada tak kena tangan keras, terbaik. Kalau ada setengah nak orang malas fikir, dia ambil pembaris, boleh, tak ada masalah. Tapi lari lah banyak lah. Ni dengan yang ni.
So 0.3 tu macam mana dapat?
0.3 ni sekarang ni dia bersilang pada garisan ni. Sekejap, saya lukis kat sini. Macam ni. Siapa tanya tadi?
Saya Azman.
Oh, first time Azman, welcome lah. Okay Man, dia macam ni Man. Dia sekarang awak dah buat dah. Katalah here. Kalau lah kita dapat, alright. So jadi kita pun buat lah, tarik lah. Close sana ni insyaAllah. Bagilah ni sikit kalau nak. Okay, katalah sini lah So jadi here. Okay, ni kita punya ni lah. Naik quiz. So sekarang dia silang pada sini. So use the skill apa yang kita dah assume tu, kita ambil distance ni. The distance from 0 ni to here. Nanti kita akan dapat nilai X. So our formula for GM is equal to 1 over X. So now our GM is 1 over, katalah kat sini 0.3. So mean kita akan dapat 3.3 lebih-lebih. Nah, boleh Zaman?
Boleh.
Okay, so kalau looking for face, katalah face here we have this is 1.0. So jadi face O, kalau kita ikut sini kan, so this is our point. So ambil ni, so this is kita punya face lah. Itu je. Okay, so jadi hari Sunday I will make extra class. So what time you prefer? 1 jam pun tak apa. It's just 1 hour. At least I give you 2 or 3 more example. Ataupun I give the example in the WhatsApp group, and then I open question and answer on Sunday. Because class another class section 9 and 10 I make at night. But this section kita buat ni lah, daytime lah. Bila? Awak boleh free bila? Pukul apa tadi? Tadi ada kelas kata can I make a class at 1 to 2? Boleh tak? Boleh So jadi I open, maksudnya I just, if you are not busy ataupun you don't have any class, you can join the class 1 or 2 1 until 2 o'clock. So at least you have any question you want to ask regarding the test 2, then please ask. Okay, so insyaAllah, thank you very much. I already take your time. Thank you very much. So good luck, take care.
Thank you, Doktor.
Bye.
Thank you, Doktor.
Thank you, Doktor.